In this video, I'd like to take a look at even and odd functions. All right, these are two special types of functions that have some interesting properties. Okay, an even function is a curve that's symmetric about the y-axis, and an odd function is a function that's symmetric about the origin. All right, and if you clicked on this video, then you've already seen two examples of functions like this. All right, but I want to take a closer look at even and odd functions. So let's dive into it. Okay, here we go. Even and odd functions. Let's start with even functions. A function is called an even function if, for every input x, we have the equation f of x equals f of negative x. The graph of an even function is symmetric about the y-axis. All right, so what does this equation really mean? What is it saying? Let's find out. All right, and let's use the function f of x equals x squared as an example. All right, we want to know if this function is even or not. All right, the question is, do we have the equation f of x equals f of negative x for every input x? Well, I don't know, right? But one thing we can do, right, one thing I can do is just choose some values for x, plug it into the function, right? Plug x and negative x into the function, and then see if I get the same thing. All right, so let's test x equals 1 and negative x, right? X equals negative 1. Let's plug both of those values into the function, and let's see what we get, okay? F of 1 is equal to 1 squared, right? That's what the function says to do. It says to take what you're given and square it. So we'll take 1 in blue here and square that, okay? 1 squared is 1 times 1, which is equal to 1. All right, f of 1 equals 1. And f of negative 1 is equal to negative 1 whole thing squared. All right, we're taking what we're given and we're squaring it, okay? And we get negative 1 times negative 1, which is equal to positive 1, okay? So f of 1 and f of negative 1 are both equal to 1. Therefore, f of 1 equals f of negative 1, all right? So do we have this equation satisfied for x equals 1? The answer is yes, all right? So what are the implications on the graph, right? What does this mean on the graph? Well, let's plot the points, all right? When we plugged in 1, we got 1, all right? So 1 comma 1 is on the graph. And when we plugged in negative 1, we got 1. So negative 1 comma 1 is also on the graph, all right? Notice that these 2 points are symmetric about the y-axis, right? They're both a horizontal distance of 1 away, and they're both at a height of 1, okay? So let's try a different x value, all right? Let's try x equals 2 and x equals negative 2. Let's see what we get, okay? F of 2 in red here, right? F of 2 is going to be equal to 2 squared, right? That's what we get when we plug 2 into the function, all right? 2 times 2 is equal to 4, all right? So that means that f of 2 is equal to 4, all right? Now let's try f of negative 2. Let's see what we get, okay? F of negative 2 is equal to negative 2 whole thing squared, all right? Take what you're given and square it, all right? So we need parentheses here. Negative 2 squared is negative 2 times negative 2, which is equal to positive 4, all right? So they're both equal to 4, all right? Which means that f of 2 is equal to f of negative 2, all right? Do we have this equation satisfied for x equals 2? The answer is yes. All right, this equation is satisfied. okay? So we can keep doing this forever, right? There's an infinite number of values that we can choose for x. Oh, by the way, here's what it looks like on the graph, right? 2 comma 4 and negative 2 comma 4, right? These red points are symmetric about the y-axis as well, okay? So back to what I was saying, we can do this forever, all right? We can plug an infinite number of values into the function f, and we can check if f of x equals f of negative x for an infinite number of x values, right? And then we can say that the function is even if we do that forever, all right? That sounds like a waste of time to me, all right? So we need a better way to check if this function is even, all right? We can't check every input x, all right? But what we can do is we can plug in negative x, right? We can say that x is arbitrary and plug in negative x into f, all right? And then we see what we get for the function formula, all right? If we plug negative x into f and we end up with the same formula, that means that f of x equals f of negative x for every input x, all right? So let's try it out. F of negative x is equal to negative x whole thing squared, okay? And that is equal to negative 1 times x whole thing squared. All right? Bear with me here. We're going to see if we end up with x squared after the dust settles. All right? There's an exponent rule that we can use to simplify this. All right? We have a product being raised to the same power, right? So what we can do is we can take this power and apply it to each piece of the product. All right? We've seen this before. Okay? So we have negative 1 whole thing squared times x squared. And negative 1 squared is negative 1 times negative 1, which is positive 1, all right? And 1x squared is simply equal to x squared, all right? So look at this. F of negative x equals x squared, all right? That's the formula. And that is the same exact formula as the original function, right? F of x equals x squared. So we have f of x equals f of negative x, all right? And this is true for every input x because we plugged an arbitrary x value, right? We plugged negative x into the function f, okay? So this equation is true for all values of x. Therefore, f is an even function, all right? And note that the parabola is symmetric about the y-axis. Okay? Let's move on to odd functions now. A function is called an odd function if, for every input x, we have f of x equals negative f of negative x. Okay? The graph of an odd function is symmetric about the origin. Okay? So let's take a look at the function f of x equals x cubed. All right? The question is, do we have this equation for every input x? All right? So if we wanted to, right, we could try plugging in some x values like we did before, right? And we can look at some points and see if they're symmetric about the origin. All right? And we can find out if the function is odd by doing that forever, right? By plugging in an infinite number of values for x. Instead, what I want to do is just jump right into the formula, right? We can find out what negative f of negative x is equal to, and that is going to be a much more realistic undertaking than plugging in an infinite number of values for x, right? So let's find out what this is equal to. Negative f of negative x is equal to negative this thing, all right? F of negative x is what's in the brackets, okay? And then we're slapping a minus sign in front of that, okay? So in brackets, we have f of negative x, okay? Let's just focus on what's happening in the brackets for now. Negative x cubed is the same thing as negative 1 times x, whole thing cubed, All right. So we're going to use that same exponent rule to simplify this, right? We have a product to a power, so we can take this power and apply it to each piece of the product. All right. -1 whole thing cubed times x cubed, right? That's what we have in the brackets. And -1 cubed is -1 times -1 times -1, which is -1. Right? There's an odd number of minus signs, so the result is negative. So we have minus this thing, right? Which can be simplified to minus x cubed. All right. A negative is equal to a positive, so we just have x cubed. All right, negative f of negative x is equal to x cubed. And f of x is equal to x cubed. Therefore, f of x is equal to negative f of negative x. Okay, so do we have this equation for every input x? The answer is yes, we do. Therefore, f of x equals x cubed is an odd function. All right? And note that this curve is symmetric about the origin. All right, so what that means is if I plug in 1, I get 1, right? I have the point 1, 1. That means that the point -1, -1 is going to be on the graph. All right? And if I have the point 2, 8, way up here it's not pictured. If I have the point 2, 8, then the point -2, -8 is also on the graph. All right? So that's what it means for the curve to be symmetric about the origin. Right? If I have a point x, y, the point -x, -y is also going to be on the graph. Okay? And that's true for an infinite number of x values. Let's look at a new function. All right? Let's look at the function f of x equals x cubed plus 2x. All right? And we're asked to determine if that function is even, odd, or neither. Okay? So let's check to see if it's even first. All right, let's find out what f of negative x is equal to. If we get the same formula that we have up here, then that means that the function is even. All right, f of negative x is equal to negative x whole thing cubed plus 2 times negative x. All right, that's what happens when we plug negative x into this function. It says to take what you're given and cube it, and then add the product 2 times what you're given, right? Okay, so we have this, and we need to simplify it. Okay? Negative x whole thing cubed is equal to -1 times x whole thing cubed. All right? And this product is -2x, so we get -2x over here. All right? Let's apply this power to each piece of the product. All right, and we'll get -1 whole thing cubed times x cubed minus 2x, right? Plus a -2x is just equal to minus 2x. All right? -1 cubed is -1. So we get -1x cubed minus 2x, which is equal to -x cubed minus 2x. All right? So let's compare the expressions, right? Let's compare the formulas. F of negative x equals this, and f of x equals this. All right? They are not the same thing. Okay? They're not equal to each other. Therefore, f is not even. Okay? Next, let's check to see if this function is odd. All right? We're going to compute negative f of negative x to see what we get, right? We want to find out what that formula is. Okay? Once again, I want to take f of negative x and put it in the brackets and then slap a minus sign in front of the whole thing. Okay? But look at this. What's this expression in brackets? We already know what this is, right? We computed it on the previous screen. F of negative x is what we have in the brackets, right? And we already simplified that, and we found out that it's equal to -x cubed minus 2x. Work smarter, not harder, right? That just saved us a lot of time. Okay? So all we need to do is distribute this minus sign to each piece in the brackets here, right? Distribute a -1. Okay? What does that give us? It gives us x cubed plus 2x. All right? And look at this. F of x equals x cubed plus 2x. So we have this equation satisfied for all values of x. All right? Which means that the function is odd. All right? So that's my final answer. That's how we can check to see if a function is even, odd, or neither. Right? We just compute f of negative x to test if it's even, and we compute negative f of negative x to test if it's odd. All right? That does it for this video. Thank you for watching, and like and subscribe.